In this video we are going to install and set up a Kubernetes cluster on Ubuntu Linux that we'll be using for all our learning purpose. But before going to that, let's discuss briefly on the architecture of Kubernetes. The Kubernetes is a container orchestration and management platform, and it is open source. So when we talk about Kubernetes cluster, we have two different type of nodes available: the master node and the worker node. Okay. Each node, the master node is responsible for management of the cluster, and the worker node is responsible for hosting the user applications. Now, if we talk about the components, there are two type of components that is there: control plane component or node component. The node component runs on each node, irrespective whether it is a master or a worker, but the control plane component will run only on the master node. So what are the control plane component? We have the API server. This is the, as the name suggests, this is the component which is the only exposed to other nodes and the outside world. Whenever a request is forwarded to the master node, it lands to the API server, who is responsible to route the request to the correct component. This component is also known as Kube API server. The next component is Kube scheduler, which is responsible for scheduling the pods to the correct nodes. Before scheduling any pod, it analyzes the load on each worker node, any policies, any restrictions in place, if there are any taints and tolerations available on that node. Only after analyzing everything, it schedules the pod to the correct node. Then third, we'll have the Kube controller manager. This, as the name suggests, it is a controlling process. There are different type of controllers, but for simplicity they are all combined together into a single binary and run as a single process. So if we talk about the controllers, we have node controller. This is responsible to determine when a node is down. Then we have a job controller. Then we have endpoint controller, and then service token and account. So as we have mentioned, this node controller is responsible to identify when a node goes down and accordingly communicate with the other components. The job controller monitors when a job is being created and launch the necessary pod to complete that job. The endpoint populates the endpoints. So the service token and account component controller is responsible to create the default service token and accounts in a new namespace. And then we have the node component, which runs on the master as well as on the worker node. So first we have kubelet, and then kube proxy. This is an agent that is running on each node, and it ensures that the pods that are launched are healthy and running according to the pod specification that has been provided. And as the name suggests, kubeproxy is a network proxy agent which implements the network rules on each node, and it is responsible for any communication, network communication internal to the cluster as well as external to the cluster. Now we will draw the interaction between components, which will make it more clear. So here we have a master node, and we have the worker node. And here we will have the control plane components, API server, scheduler, controller. So these communications happen by direction here, this, and then you have kubelet, and kubeproxy. And then you have the API server communicate with kubelet and the kubeproxy as well, and this is the node components. In worker node also we will be having node components, kubelet and proxy. So again the API server is responsible for this communication. So this is on a high level the cluster architecture. Now let's go and learn how to install the Kubernetes application and the cluster setup. Also, before installing the Kubernetes on each node, we need to install the container runtime engine. Those who are not familiar with containers, please refer to our blog post as well as our YouTube videos on this topic. Now Kubernetes supports the following container runtime as per their documentation. The first one is containerd, then we have CRIO, and the last one is Docker. This is the most popular one, and for all our learning purpose we will be concentrating on Docker, and we will be using this as our container runtime engine. Now let's move to our cluster setup and Kubernetes installation. Now we have a Ubuntu desktop on which we will be installing the Kubernetes cluster. Let's see the OS version. So it is 21.04. Now to install Kubernetes, we don't need to remember all the commands by heart, because we have a very good documentation which gives us clear-cut instruction how to install. So here we will go to the version and select 1.21 for our installation. Later when we will do the cluster upgrade, we will upgrade it from 1.21 to 1.22. So here we have learning environment and production environment. The learning environment gives us few tools like Minikube, but we will be going and installing the Kubernetes as per the production environment. So first let's install the container runtimes. We already have a separate video which gives detailed instruction, but still we will be showing you how to install the container runtimes in this video. Now to install Docker, we go to docker.com and select Ubuntu as our operating system to get the proper instructions. First we need to uninstall any existing version of Docker. So for that let's see if Docker is installed. We can see it is not installed, so we can skip this step. And now we need to install certain prerequisite packages. So most of them already are out of the box from Ubuntu, but still we will run it to install any missing packages. Most of these are already installed. Now we go to the official documentation again and copy the official GPG key. This we need to add. Next we need to add the stable Docker repository. Now we update the apt repository and I'll install Docker Community Edition and the Community Edition CLI. So in the instruction we are seeing that it is calling separately containerd.io, but we will not be installing it separately because Docker itself will install it, and this is done from version 1.11 onwards. The version installed is 20.10. Next we add our current user to the Docker group so that we can run Docker commands with our user and don't have to log in as root. Now we can see that Docker commands are running with normal user. Next we go back to our Kubernetes web page and configure Docker daemon to use systemd. So here you can see the CG group driver systemd has been set. Next we need to enable Docker at startup and restart the Docker. Next we select install Kubernetes with deployment tools, and there we will select kubeadm for bootstrapping our cluster and then installing kubeadm. For installing kubeadm we need some setup to let IP table see the bridge traffic. So for that we run the provided steps. Next we need to enable or open certain ports in our firewall. So because those ports are required for intercommunication. So in Ubuntu we have UFW status as enabled, and so we need to open these ports. So we will go back to our web page and start allowing each of these ports. Apart from these ports we will also allow HTTP and HTTPS. Now we go back and follow the instructions for Debian or Ubuntu Linux. So first we will need to update our apt repository, and then we install certain prerequisite packages. If we remember, these are the packages which we have already installed when installing the container runtimes, but we will still install it. If there are any dependencies left over, then we may face issues later on. The next two steps are to add the Google public signing key and then adding the stable Kubernetes repository. Now we have cleared our screen and we are updating the APG repository, and then we will be installing the Kubernetes version 1.21. For this we need to install kubeadm, kubelet and kubectl with version 1.21, and then hold these packages so that they cannot be installed or uninstalled or upgraded. Now we can see 1.21 version is installed. Now we clear the screen, and then we need to find out the IP address for the API server, and next we need to find a pod sider network. For our demo purpose we will be using ViVNet, so our pod sider will be 10.32.0.0/12. okay, so we are initializing the Kubernetes cluster, and for this we will be copying these arguments from our Kubernetes documentation. Our initialization has failed because we have not disabled swap. So what we can do, we can swap off -a and disable the swap, but this will again be enabled during reboot. So to make it permanent, we need to comment out the swap file line in etc fs tab. After we have done this, we again run the initialization command, and this time it should start successfully and complete. We will pause the video because it will take some time to pull the images and set up the cluster. Now if you go up and see where it is mentioned that swap file must be disabled, now you can see that before we begin we must disable this app, which we have overlooked and missed out. Our Kubernetes setup is now completed, so we need to run these instructions as mentioned on the screen. This will allow the kubectl commands to be executed from normal user. Currently we are not able to execute it. Once we run these commands, we are able to execute these commands. Now as you can see, our node's status is not ready. This is because we have not installed any pod network, and that is the reason our core DNS is not up and running. Now here we will be getting the links to install the different pod networks available. So if we go to the section install a pod network, and there we click the Kubernetes supported ones, here we will see ViVNet from VWorks, so we click ViVNet. After we click install, it will open a new page from where we can integrate Kubernetes via add-on. This section will give us the command that we need to execute to install the ViVNet for our Kubernetes cluster. Now let's watch if all the pods core DNS as well as our ViVNet is up and running. Once that is up, we will see our node status change to ready. Now we can try running a pod on this Kubernetes cluster, which is a single node cluster, but this pod will not run because there is a tent in place which has a effect no schedule on the master node. This is a default behavior of Kubernetes, that when a cluster is initialized, the master nodes are made as no schedule. That is, no user defined pods or applications can be hosted on the master node, but because our cluster is a single node cluster, we need to make it schedulable. So let's see if our pod is up and running or not, and then we will try to fix this issue. Now here you can see the warning that the scheduling of this pod has failed because there are no nodes available. The master node has a taint which the pod didn't tolerate. You can check the node and identify the taints that is in place. Next we need to remove this taint. There is no separate command to untaint a node. You just need to put a minus sign at the end of the taint command. So for this we are executing the command. Okay, there was a mistake because we did not provide the resource type. It should be kubectl taint node and then the node name and the taint name and then the minus sign. So our node is tainted. Now we can run a new application and also our existing application will be up and running. Now you can see our first application was pending. It is up and running, and the second one is also up and running. Thanks for watching this video. Subscribe to our channel if you like it.